Hello friends, this is Gurpreet. In this video, I would like to tell you about non-ferrous metals. Whenever you come across the word non-ferrous metals, what is the first thing which comes into your mind? What does ferrous metals means? Ferrous metal means those which contain iron as their chief constituent, whereas non-ferrous metals are those which are quite opposite to that of the ferrous metals. These don't contain iron as their chief constituent. There are different non-ferrous metals like copper, aluminium, zinc, magnesium, titanium, etc. And it is usually seen that non-ferrous metals are more expensive than those that of ferrous metals. They are also used in different industries for engineering purposes. It is because they have certain characteristics like they are light in weight. They have good electrical and thermal conductivity. They have resistance towards corrosion. As they don't contain iron, so the possibility of getting corroded is less when compared to that of ferrous metals. So because of this, they have high resistance towards corrosion. They're attractive in colors. And the ease of fabrication is by rolling, welding, machining, etc. Among non-ferrous metals, I would like to tell you about copper. Copper is the most oldest and the most widely used non-ferrous metal. We come across copper in our day-to-day life. It is used for various purposes. And not only that, copper has some properties which makes it even more special and more useful. Like copper has the property of ductility, malleability, that is, it can be drawn into wires and it can also be drawn into sheets. It is soft in nature. It is used in both hot and cold working. It is light in weight. As I told you in the beginning, that non-ferrous metals, they have a characteristic that they are light in weight. So copper is also a non-ferrous metal and it is light in weight. It has good electrical and thermal conductivity. It is non-magnetic in nature and it can be alloyed with any of the other metals. Other than the general properties, you can also see the mechanical properties. The slide shows the different mechanical properties like melting point of copper, density of copper, Young's modulus of copper, and tungsten strength and hardness. Hardness of copper, which is measured using Brinell hardness number. So this is about the properties of copper. And next I would like to tell you about the process of extracting copper. So copper is extracted from copper pyrites. This extraction is done by using four processes mainly. The first process is crushing, the second is concentration, third is roasting, and the final one is smelting. So in the very first stage, that is crushing, what are we doing? So in this process, the copper pyrites, they're crushed into powder. And in the second stage, that is in concentration, this powder, it is mixed with water, it is filtered and it is air blown. And when it comes to the third stage, that is roasting, so in this stage the copper pyrites are combined with iron and sulfur, and because of this iron and sulfur, copper iron sulfide and is formed, and this is then mixed with silicon oxide and oxygen. So there's a reaction in the slide where we can see that copper, it reacts with silicon, not only copper with a combination of iron and sulfur, it reacts with silicon oxide, and here comes a product of copper sulfide, that is Cu2s. So the last stage, as I told you, it is smelting. So it is a metallurgical process to obtain pure copper from copper pyrites. So in this process, we are taking the copper sulfide which is formed in the reaction and in the above reaction, and this copper sulfide, when it reacts with oxygen, then we get pure copper. So this is the way in which we are extracting copper from copper pyrites. Now let us come to the applications of copper. Copper, as I told you, that copper has a property of ductility. It can be drawn into wires, and when it can be drawn into wires, it is used for various purposes, like it is used for power cables, for telephone cables, for computer network cables, and etc. It is used in heat exchangers and heat vessels. As I told you that copper, it is having a good thermal conductivity, so it can be used in heat exchangers and heating vessels also. It is also used for many more applications, like because it has a property of good corrosion and because of this it is used for various applications. Now, when we come through the alloys of copper, there are mainly four types of alloys of copper. The very first alloy is brass. Brass is simply a combination of copper and zinc. Then is bronze. Bronze is a combination of copper with tin. And gunmetal. Gunmetal is something which is the combination of copper, zinc and tin. And cupro-nickel alloy. Cupro-nickel alloy, the name itself says that it is a combination of copper with nickel. Now when we come to brass, brass has three types. Brass, again, it has a subdivision that it is divided into three types, that is alpha brass, beta brass and alpha beta brass. So alpha means it is high ductile and beta means increases strength. So when you come to alpha brass, the alpha brass is that which contains less than 20% of zinc. So first thing I told you that brass is a combination of copper and zinc. So if in this percentage, even in this composition, if copper percentage is less than 20%, then we tell that it is a alpha brass. So alpha brass is simply known as red brass. Now next, when we come to beta brass, it has the percentage of brass about from 20 to 30%, and it is also called as yellow brass. Whereas alpha beta brass is the brass which contains the percentage for about 30 to 45% of zinc. So these are the different types of brass we use. So there are more. Now there are many more other brass subdivisions like red brass, grinding brass, low brass, commercial brass. So these are all the brass which comes under alpha brass, and there are many different brass which comes under beta, that is which can be seen in the slide, and alpha beta brass also has many divisions. Thank you.